Okay, let's dive into this. Have you ever stopped to actually think about the invisible assistant quietly running your life? Today, we aren't just going to rehash textbook AI definitions. No, we're going to unpack exactly how complex algorithms are powering the real-world business apps you use every single day. If you've ever wanted to know what's really happening under the hood of that supercomputer sitting in your pocket, you are definitely in the right place.
So think about your morning routine for a second. Did you wake up and instantly unlock your phone using Face ID? Or maybe you asked Siri or Alexa what the weather is going to be like? Well, if you did, you were actively using artificial intelligence before your feet even hit the floor. You were relying on computer vision to scan your face and natural language processing, or NLP, to parse your voice commands. AI isn't just some sci-fi robot from the future. It's the technology that's already here, doing things that usually require human intelligence, like recognizing patterns or understanding speech.
Now, the actual engine driving the vast majority of these everyday apps is a subfield of AI called machine learning. Instead of the old-school computer science way, where a programmer has to sit down and write out explicit rules for every scenario, these algorithms simply learn from data. And this approach has totally exploded over the last couple of decades. Why? The internet. As businesses brought everyone online, they started hoarding massive datasets. Companies like Google, Amazon, and Uber finally had the insane amounts of data needed to make these machine learning applications incredibly accurate and totally viable for business.
To really get how this works, let's look at a classic business application, a bank loan approval system. The whole machine learning process basically happens in two distinct steps. Step 1 is training. This is where the algorithm crunches historical data, thousands of past applicants, their credit scores, their salaries, and whether they ultimately paid back their loans. It's digging for hidden patterns. Then comes step 2, inference. When you, a brand new applicant, walk through the door, the system uses that freshly trained model to make a prediction on your specific data. It uses the past to predict your future, deciding right then and there if your loan gets approved.
Now, what's really interesting about this slide is how this type of supervised learning, which is where we train models on clearly labeled historical data, breaks down into two main types that businesses use all the time. First, you've got classification, where the output gets sorted into predefined categories, like a simple yes or no. And second, you have regression, where the algorithm's job is to predict a specific, continuous numerical value.
Let's look at classification in action during that morning routine of yours. You open up your Gmail, and an AI has already neatly sorted your inbox. How? Well, it analyzed the incoming data, checking if the sender's email looks sketchy, looking for weird external links, or spotting way too many exclamation marks and fake promo keywords. Because the end result has to fit into finite, predefined categories. In this case, it's either spam or not spam. This is a textbook example of binary classification.
But what about lunchtime? Say you order food on an app like Uber Eats, Swiggy, or Zomato. The second you hit order, the app gives you an estimated time of arrival. Now notice the output here isn't a category. It's not just fast or slow. It might say 15 minutes, or 23 minutes, or 45 minutes, depending on distance and traffic. Because the app is predicting a specific numerical value based on past writer data, it's utilizing that second type of supervised learning, regression.
Okay, fast forward to your afternoon errand. Here, you're likely brushing up against unsupervised learning. In this scenario, the AI model is fed raw, completely unlabeled data, and it's told, hey, go find some hidden patterns or groupings on your own. A massive business use case for this is called market basket analysis. E-commerce giants like Amazon analyze millions of shopping carts to find hidden associations. If the algorithm realizes that people buying bread are also super likely to grab milk, it creates an association rule. And that right there is exactly why you're constantly seeing those frequently bought together recommendations.
But unsupervised learning isn't just about selling you more stuff. It's also the silent guardian of your finances. Because these models are so insanely good at figuring out what normal data looks like, they instantly spot when something doesn't fit. We call this anomaly detection. Imagine a cybersecurity system sees a single user logging into a bank account from 5 different cities in under 1 minute. There is no way a human is doing that, right? The system flags that data point as a massive outlier, immediately blocks the transaction, and saves you from credit card fraud.
Now for the third main branch, reinforcement learning. The absolute easiest way to wrap your head around this is to think about training a puppy. If you tell your dog to sit and they actually do it, you give them a treat, a reward. If they chew up your shoes, they get a penalty. Reinforcement learning works exactly the same way. An AI agent is dropped into an environment, and it learns to make a sequence of decisions purely through trial and error, trying to maximize its rewards. This is the exact same tech used to train self-driving cars to safely navigate traffic, or to build AI bots that can completely crush human grandmasters at chess.
Okay, so practically everything we've touched on so far falls under statistical machine learning. And that stuff works beautifully for neatly structured tabular data. Think massive spreadsheets of housing prices or bank loans. But think about your evening commute. You're completely surrounded by messy, unstructured data. Scrolling through YouTube videos, streaming audio, driving past raw image feeds from traffic cameras. Statistical ML actually struggles pretty hard here. To process this ocean of unstructured data without a human having to handhold the system, businesses have to rely on a much more advanced subset of machine learning called deep learning.
To really grasp why unstructured data is such a headache for computers, just think about this number. 1 million, 10 to the power of 6. If you try to feed a relatively tiny 1,000 by 1,000 pixel black and white image into a standard neural network, the computer sees it as a giant grid. That means it has to process 1 million distinct input pixels. In a standard setup, a single artificial neuron would have to perform 1 million computations just to process one simple colorless image.
So the crucial point is that out in the real world, we aren't dealing in black and white. We're dealing with color images, which means overlapping red, green, and blue grids. That instantly triples the computational load to 3 million calculations per neuron. Now imagine a video, which is literally dozens of color frames every single second. A standard network would completely choke on that. And that's why deep learning relies on convolutional neural networks, or CNNs. Instead of trying to swallow every pixel at once, CNNs are clever. They scan small patches of an image step by step, looking for edges, then shapes, then whole objects. It's this optimization that makes real-world business applications like real-time traffic analysis and self-driving vision actually possible. But how do these neural networks, which are loosely inspired by the neurons inside our own brains, actually learn anything? Well, think of a college professor calculating your final grade. The professor assigns different levels of importance to different tests, right? Midterms might get a 0.4 weight, end terms get a 0.4 weight, and those annoying little pop quizzes get a 0.2 weight. Now, if the professor notices everyone is skipping class, they might tweak the logic, bumping the quiz weight up to 0.3 to fix the behavior. Deep learning neurons do exactly this. They take in multiple inputs, multiply them by these specific internal weights, add a little bias, and pass the final result forward.
Let's move to and see how this builds into the actual training process. It basically requires two major steps. Step 1 is forward propagation. The network takes the input data, runs all those weighted calculations we just talked about, and spits out a prediction. Basically, it takes its best guess. Step 2 is backward propagation. The network looks at the actual correct answer, figures out exactly how wrong its guess was using something called a loss function, and then works backward through its layers, tweaking all those internal weights to make sure the error is smaller next time. It literally learns from its mistakes, just like we do.
All right, as your day wraps up and you're finishing up work, you might turn to the absolute rock star of deep learning right now, generative AI. Unlike the older models that just categorize or predict things based on existing data, Gen AI builds entirely new content from scratch. And businesses are deploying this literally everywhere. Need text? You've got large language models like OpenAI's ChatGPT. Need images? You boot up Midjourney. Video? There's Sora. And for software developers, writing code is now heavily assisted by tools like GitHub Copilot.
And this brilliantly illustrates the specific deep learning architecture that makes tools like ChatGPT so mind-blowing. Transformers. Older AI networks process text word by word, sequentially, which meant by the time they reached the end of a long paragraph, they'd totally forgotten what the beginning was about. Transformers flip the script. They process sequential data as a whole block and use this incredibly smart attention mechanism. If you type, "the dog chased the cat because it was scared," the attention mechanism does the math to understand that it refers to the cat, not the dog. This is what gives these models their remarkably human-like grasp of context and conversational nuance.
So from the second you unlock your screen in the morning, to the exact route you take to work, to the emails you draft, AI is quietly optimizing your life. But here's the thing you have to remember. The massive billion-dollar models being built by tech giants right now rely entirely on a constant, unending stream of human data. You aren't just passively using these tools. Your daily routine, your choices, and your habits are actively generating the raw data that trains the AI of tomorrow. So the only question left to ask yourself is, what patterns are you leaving behind?